I bought a Cartek isolator and I've been working out how to install it in the car. Now the standard type of isolator, which you can see here in this bottom picture, it has effectively two switch circuits. The first one switches the main battery feed, so you have the battery connecting to this side of the connector, and then the other side goes on to the fuse box and starter motor and generator. And this is the high current circuit, if you like. The problem is that if you cut that, if you switch the car off and so cut that connection, because the alternator is still wired onto the positive rail, the positive feed, the car will keep running because it can run without the battery, because the generator, the alternator can provide the 12 volts. So what you then also have to do is you have to use this second switched circuit, which is provided by this other switched area here, to cut the feed to either the ECU or some other part of the car that makes it run, and I'll just explain later how I've used it to switch off the power feed to the injectors. So that's a standard type of setup. The Cartek one is slightly different. Remember, this is in this lower one, the rotary switch, you switch the positive feed. In the Cartek setup, you actually switch the negative. So you can see that the negative from the battery connects to a terminal on the isolator, and then with it enabled, with the whole system enabled, the circuit is completed through the frame of the Cartek isolator. So you can see here it's got the little earth symbols. So the path for the negative side is through here and then out through the frame and onto the chassis. Now the other part, the low current part that we spoke about, is done through this arrangement here, these two terminals here. So you can see we've got a positive supply from the battery, goes through the Cartek isolator and then out, and it says to engine electrical system, ECU or ignition switch. So you're switching that low current part so that if you hit the isolate button, kill, as it says here, external kill button, or if you switch the car off through the internal button, what you do is you cut the negative path, and you also cut the path for the positive feed to the electrical system. So that's how it works. Now, everybody there's been a bit of chit chat going on the forums about what you should and shouldn't cut on the BMW 116 trophy car, the BMW E87 N45, for those of you who are not into 116 trophy. And the way everybody seems to do it is they cut the feed coming out of F03, which is fuse number 3 that's in the ECU box. We'll see it later on in a video. And they do that with the rotary switch. So they cut the positive feed in the normal way. So the big battery cable goes through the switch and out the other side. And then there's this feed from F03, which they run a wire out of the ECU box in the front of the car into one side of the switch, and then out of the other side and back onto the rest of the circuit that was connected to F03, fuse 03. So that's how it's done. So I wanted to figure out a way to do the same thing with the Cartek isolator, and this is what I came up with. If I can just get this to change. So I used a relay. Basically, I'm using a relay to simulate the low current side of the rotary switch. So you can see here that we've got fuse 03 here, comes into the relay, it's normally open, and then it would go on and feed the injectors. And so once the relay is energized, that closes this circuit and then we get the complete feed into the injectors. I've also decided we need a fuse in close to the battery isolator, because if I had a short anywhere in the circuit to the relay, bearing in mind my battery isolator is going to be in the back of the car and the relay will be in the ECU box, I've got a long run of wire, and so if it chafed or anything and shorted, I don't want it blowing up the battery isolator. So the lowest fuse I could find, lowest rated fuse I could get my hands on at the moment, is a 3 amp fuse. For a car type, I did debate putting in a barrel type of connector and using just a barrel fuse, but in the end I went with the 3 amp car type fuse, mainly to avoid me having to carry lots of different types of fuses for spares, because these ones are the same size and shape as the ones that are used in the fuse box in the car. Okay, so that's what we're trying to achieve. So now I'll cut to the video, or the video footage that I've got of actually installing it in this way. When you install a rotary style cutout switch, you have the big main terminals that cut the power from the battery, and then you have the normally open switch on the back, which is used to switch off a circuit in the ECU box. Now there's a bit of debate been going on a forum about whether you should switch off the ECU, which is fuse number 4, which is this red and yellow wire, or fuse number 3. I've gone with fuse 3 because that seems to be what everybody does. Now in fact that doesn't cut the power to the ECU, it cuts the power to the injectors and the crank and cam sensors. So the way I'm going to do it is I've cut the fuse 3 circuit, the one to the injectors, and I've interposed a relay, normally open relay. And then I've wired in an earth wire, and then what I'm going to do is I'm going to bring a wire, single wire, all the way from the Cartek cutout unit, which is located in the back of the car, all the way along the transmission tunnel, then up through this area over here where I've got these other wires coming up, and then I'm going to plug that onto there. The idea is that when the Cartek unit is in disabled mode, there won't be power feed to this, and then when it's enabled, when I press the various buttons to enable it, then we'll get a feed to this. That will energize the relay, that will close the circuit, and the injector circuit will be powered up. The relay is a 40 amp relay. It's from Halfords actually. So this is the unit I'm using. Can just get that to focus. HEF 560. You notice it's got a diode. The reason I've chosen one with a diode is that when you open the circuit on something like a relay, you do get what's called back EMF. So you get a pulse of reverse voltage coming out of the relay coil. I didn't want that to feed into the rest of the electronics, and so what I've done is I've chosen the one with the diode, which basically just eliminates that back EMF by shorting it. It effectively applies a short across the relay when there's current flowing in the opposite direction. It does mean you've got to make sure that you wire this up the right way round. So if you're going to use one of these units, make sure that you wire the earth to the this side of the diode. So it goes to pin 85, I think it is. Yeah, pin 85. That's got to be the earth, and then the other side is the switched live, which comes from the Cartek unit. It's a bit of a shame that these pairs are not longer. They need to be about 30 centimeters so that I don't have to join it here. I'd rather join it, somewhere underneath all this lot, not sort of open under the bonnet here. I was going to use a plug and socket type of arrangement, but because it's going to be exposed to rainwater and whatnot, I think I'm going to have to just solder it up and then put some heat shrink tubing around it to just seal it right off. I'm going through a period of just making repeated mistakes. It's really frustrating. So I've put a ring connector on this, but I need an inline fuse to go in there yet. So that's going to have to come off. I've obviously put this in the wrong place. This needs to come down a bit. So I need to release this and move that back. The other thing I did yesterday is I decided that I was going to mount the battery cage on the floor here and put the battery in that. Well, that all went completely wrong because where I drilled the holes this side, I hit a double sort of box section, which would have been all right, except for I've hit the sloping part. And so you can see it's torn sideways across where I've been drilling. So that's been a bloody disaster, which is really annoying. And now I'm a bit miffed about what I am going to do. I was going to mount it here, but I am concerned about it being so close to the fuel tank behind, you know, so drilling, okay, I can protect the fuel tank while I'm drilling, but the riv nuts, if I'm going to use riv nuts, they're going to come really close to the fuel tank, and I do not want them wearing a hole through the fuel tank. So the floor is still looking favourite. I think I'm going to try and move it across, but if I move it across like that, there isn't enough space for the riv nuts, so I'll just have to use bolts down through the floor. I don't know, it's just, yeah, this has not been my finest hour, quite honestly. This last 2 days, so much has gone wrong. I've made so many mistakes. They're rectifiable. I mean, I haven't done anything particularly destructive, but you know, it's just frustrating. I had intended to use these crimp connectors so that if I wanted to remove the Cartek unit, I could do it quite easily. And I did the same at the front on the switch for the dash. They are really flaky. They're not. I've not got any continuity on them at the moment, but if I mess around with the wires and the connectors, suddenly it'll, you know, it'll actually make the circuit and I'll get some continuity. And yeah, it's way too flaky. I can imagine, you know, racing and having all sorts of intermittent sort of ignition problems and cutout problems. So I'm not going to do that. I'm going to cut them all off and I'm going to solder them. Because I just think that's far safer. Big lesson that I thought the crimping, you know, I've heard that if you crimp them correctly, they make a really good connection. And I accept that maybe the diameter of the wire is not perfect for the size of the crimps. I mean, I'm using the smallest, the crimps with the small that accommodate the smallest gauge wire. Well, certainly the smallest ones I've got, but yeah, it's too risky. I'm going to cut them off and I'm going to just solder it all up. Well, soldering them up has made all the difference. So just to explain, I've got a 3 amp power supply. The reason I'm using it is because it's got a current limiter on it and also an ammeter to tell me how much current is being drawn. And then I've got my multimeter across the output, and if I press the button on the dash, sure enough, we get 12.5 volts, and it's reading on the ammeter about 200 milliamps. So that's the relay that's drawing that. Naff all, really. So that's what I wanted. I mean, it should be drawing very small amount of current. So that's all looking good. I will check the relay to make sure it is actually being activated, but it should be. Now I've got the meter across the relay, so when we hit the button here, there we go, squealing. Let's leave it like that. Okay, now if I hit the cutout switch here, yep, that works. Good stuff. Okay, here it is in place with the fuse. Obviously I've still got to install the battery connections, but it's pretty much done now and it looks fairly neat.